This is the demonstration for the Microcontrollers 2 Project 2. For this project, what we're utilizing is a function generator that produces a 0 to 5 sinusoidal analog waveform, and we're using this oscilloscope to read that value just for diagnostic purposes and to display that we're getting a signal. This is our setup. As you can see, we have the analog value going into analog channel 1 of the Arduino. The Arduino reads this analog signal and then stores it into, it adds a randomized character between 1 and 10, a comma, and then the value from 0 to 1024, and then sends it into the COM port that we're using. And in this case, we're using COM4. So this is our code for the module. Module 1 was given to us by Mark. It allows for communication from the COM port and the VBA to be established. But Module 2 was a modified version of the Excel document that was also given to us. What we do is this code allows for the separation of the data coming in through the serial port, and then it's at the comma, and then stores the PV into an array and the value into an array as well. And then it stores it into the tables samples, its PV, its value, and its percentage. So going over to the actual access database, we have two tables, samples and PVs. So samples was the one that we said that we're going to insert the data into, and if we refresh this, all the data that we've been reading for a little bit of time will appear, which is what we want. So what I'm going to do is I'm going to stop the operation, so no more data should be entering in there. I'll refresh this samples table once more. So this samples obviously has our PV from 1 to 10, but it's obviously not organized just yet. The value at that given timestamp and the percentage out of 1024. So this is our PVs table. Using a one-to-many relationship, we store all the PVs at 1, which we just assigned as pressure, and so on. And then we have our queries. So we can go to the query averages, so it'll collect all the currents at different timestamps and then show the average of the value at the time and the percentage average at the time. And these are the totals. So it'll take the PV 1, 2 through 10 and then sum all the values at that given timestamp and then indicate what the process is. In this case, we have random ones like pressure, temperature, flow, and such. The last query we have is query all data. This query right here will allow us to select an individual process and then collect all the data relating to it, and then that'll allow us to turn into a graph. So let's test. So let's just say, well, it looks like pressure's right here, so let's use pressure. As you can see, now a new table has been made. It's called DV data. DV data, all the pound signs, that just means that the timestamp needs to be expanded. But this shows all the pressures, all the timestamps involving that pressure, and then the averages of those. Now that this table's made, this graph can now read the values and then store it, showing the new graph. And we can